Hello folks, and that question that you might have for me straight away is that inverter whine that I hear? And indeed it is. So let's get straight to what's causing that. Say hello to our trusty Lexus GS450H gearbox and inverter, which is now making a long overdue return. And of course some moron now has to start cutting grass with a petrol mower, of course. Thank you, Mr. Moron. Right, where were we? Ah yes. Our trusty Lexus GS450H gearbox and inverter are now connected up. They are connected to this thing with its nice flashing amber LED, which is our open source controller. We have a nice E60 Hall effect throttle pedal here. So let's have a look at our gearbox and see what happens when we press the throttle. We start spinning. We're spinning MG1, which you can see spinning here. We're also spinning MG2. And we're doing this with the original Lexus inverter. And we are controlling it with our little open source controller board here, which is convincing the Lexus inverter that it is still in a Lexus. So, first successful test of this inverter just pretty much now. So I thought I would make a video about this and give you guys a good update on the whole thing, what we're doing with this, etc. But I thought, just for those of you that don't have time to listen to me ramble on for the next 20 minutes, that I would spare you the pain and just show you spinny things. Spinny things. We like spinny things. Of course, my multimeter has decided at this time that the battery decides to fail in it. But to show you what we've got going on here, we have the Lexus gearbox in its original form connected to the inverter in its original form. This is the second of two of these gearbox and inverter sets that I got earlier in the year. This one actually belongs to Dave. I've just been using it here for experimentation purposes. The second one, you may recall, is physically installed in our E65 7 series. So we will be getting that car moving very, very soon. Now, you might see all these crazy loom and stuff here and think, oh, that's super complicated. Well, it's not, because we don't actually need most of that. Over in this box here, you'll see what I don't need from my loom. I've just pretty much left this one intact. But pretty much all you need are these few wires and connectors here, and in a later video I'll go through all the kind of boring technical bits. And then you simply need one of these controllers here to send the control signals to the inverter over these four control digital thingy-bob cables here. It's a synchronous serial system. It's kind of weird, but it uses CAN transceivers to send synchronous serial, so yeah, for weird. But it's not that complicated to run from a hardware point of view, as you'll see from this little board here. And I've got some very simple software working on this at the minute. It's not doing too many things. It's just basically taking a throttle press here and just turning that into a torque command and basically spinning up the motors. Now we're running from about 40 volts at the minute, and that's directly connected into the high voltage bus on the inverter. That's the only kind of a modification that you need to make there, because we are bypassing the booster converter in here and just going straight in to the inverter's DC link. But yeah, this is pretty much just the first successful test here of our system. Now, one thing that I only recently learned was these gearboxes have a external 12 volt driven pump there. You might be able to see it, and that pump is what lets us use this in an electric vehicle project, because this has got a 2-speed hydraulic planetary gear set in here. Now, to shift that, we need hydraulic pressure. The problem is that we want to be able to use the 2 motors in here to propel the vehicle. And in order to do that, we're going to be locking the input shaft here so that it can't turn. And that means that the mechanical oil pump that would have been driven by the internal combustion engine that would have been on here cannot turn. So we can use the external 12 volt pump. Now, problem is, and I didn't realize this pump is a little 3-phase motor as well, and it needs a controller that connect on to these wires here. Now, fortunately, I was able to pick one up quite cheaply for around 30 euros on eBay. But do watch out if you're getting one of these guys, because you will need that controller. And some people like to try to charge 200 and 300 euros for them, so don't pay that. Anyhow, so can't run it too much then, because we don't have that oil pump running at the minute. The little controller here will provide the control signals that that pump needs. They're very simple. So yeah, that's kind of about it, guys. I'm not going to prattle on for too long, but we can now run our trusty Lexus gearbox and inverter using its own brain with our fancy little open source controller board. Now, so yeah, that's it, simple as. So what I'm going to do is I'll cut this one here. I know there'll be some people who will be probably want to know a lot more about, you know, where do I get it and all this kind of thing. That's a bit more of a story, and I will, you know, get into that. They are quite widely available, so don't fear. We'll know fairly soon how it drives with the E65, so we'll be able to give you some more feedback there. The controllers will be available in my web shop, as will the bare PCBs, and as always, this is an entirely open source design, and there'll be a link in the description to GitHub where you can download the files and build one for yourself if you so wish. So, also there'll be links in the description there to PayPal and Patreon in case you should wish to financially support me in any of these insane projects. And link in there to the Open Inverter Forum also, where you can get more information on this and a lot of the other related EV projects that I'm working on. So, I'll leave you there. Don't forget to dislike, don't share, and unsubscribe. And until next time, happy synchronous serial interfacing.